Hello, Dr. As. I'm not sure if I'm
Hello.
pronouncing your name correctly, so please
Yeah,
correct me if I'm
it's
wrong.
okay. It's okay. It's okay, sir. So, how are you, sir? So, shall I start, sir?
Yeah, you can start.
Yes. Now, let me thank the organizers for giving me the chance and the viewer for sparing their valuable time to hear to my lecture. Now, slide one. Now, this concept has been published in Asian Journal of Immunology in April 2nd. From that, I have remade the talk to suit to a public-oriented talk. Now, the synopsis of this talk, you can see that I want to deal it in the following heading: present status of local immunity concept, inception of the concept, central theme of the concept, basis of the concept, and the means by which the concept works, and the hypothesis based on the concept, and application of the concept. So these are the things. Now, coming to the first thing, that is, what is the present status? Regretfully, I have to state that this concept of local immunity has has not received the recognition or from the scientific community or from the media. So in as much so, I call it the Cinderella of immunity. Now, if you look at the scientific community, more and more they are leaning towards the adaptive immunity, be it in the development of passive immunity by plasma treatment or developing a vaccine. All these are related to the adaptive immunity, and more important, which is ignored, is innate immunity, which is the first to deal with the pathogen. Anyway, now my presentation or this concept of local immunity may add a new dimension to the current line of thinking, and that's what I hope. Now, the word immunity is very much heard nowadays around, and so is COVID-19, or rather, COVID-19 is heard as frequently as immunity. Any way you like.
Dr. As,
Now,
sorry to interrupt. Are you able to we're seeing the PowerPoint, but it's not showing the full view of the presentation. Uh, are you using the presentation to the
yeah, I
power?
am using presentation by slides,
Okay. Could you share
and
the
the slides will be
full screen?
yes, yes, slides will be projected, and they will be removed after a minute or two, and I will continue the talk. Yes,
Okay.
okay,
Okay.
okay. So this is about okay. Now, can I start again?
Sure.
Or from the where I left. Anyway, I'll come back to this inception of the concept. This concept has been enunciated by one Professor Bresredka working in Pasteur Institute in 1924. It is almost 4 years short of a century since its inception, but not much attention has been paid to it. Now, the purpose of bringing this concept at this juncture is its relevance to the context of COVID-19. Now, what is pardon? What is the core concept? So, the pathogen which enter through the tissues of a body of system of they encounter resistance from the cells, which also accord protection or immunity. So this is the immunity that is offered locally by the tissues at the level of entry of the pathogen. Now, this is distinct from systemic immunity, under which you deal with adaptive and innate immunities, where the immune equipment is transported from elsewhere to the point of entry of the pathogen. Say, for an example, from the blood or distant lymphoid tissues and all that. So here the advantage is all these are recruited from the local resources. Now, what is the basis or the proof of this existence of this local immunity concept? Now, this local immunity concept is based on the local defenses that are available in the respiratory system, the experimental proof provided by Professor Dresredka, and thirdly, the experience we have or we had by applying the principles of mucosal immunity or local immunity concept in the case of certain bacterial and viral diseases, which we'll see. So, which we'll see later. And this is the basis. Now, the means how this local immunity exerts itself. So, this system of local immunity integrates the local defenses that will be considered shortly, along with the mechanisms of the innate and adaptive immunity. And finally, it is an integration of all the three that sees that the pathogen is prevented from entering, or if entered, is thrown out. Now, slide 1, please. I will just briefly go through these defenses because there is no time to deal with each and every aspect of this. So, the natural defenses that are present in the respiratory system are first aggregates of lymphoid tissue. These are in the form of localized aggregates that are tonsils and adenoids, and diffusely they are distributed in the form of mucus associated lymphoid tissue. Now, I'll show the image. You can see the image. Can you? Hello? Yeah. The image you can see. This shows the various type of tonsils, 4 types of tonsils and their location. And the lower one will show you the position of the adenoid in relation to this tonsil. So these are aggregates of lymphoid tissue present at all strategic points of entry of the pathogen, either through the nose or through the mouth. So everybody knows of these names: lingual, palatine, pharyngeal, tubal, and all this. I don't go into those details. Especially adenoid is an additional protection in the children, which wanes off before the puberty or by the end of the 13th year. Now, how does it help? So this lymphoid tissue trap and almost kill the bacteria, and also they mobilize B lymphocytes which secrete the antibodies, and T lymphocytes which supply the killer cells. Also, they are implicated in cell-to-cell signaling and cell-to-cytokine signaling. So that's about the lymphoid tissue. The second one and third one act in conjunction, and that is mucus and cilia. Now, mucus is a thick viscid secretion secreted by the goblet cells of the epithelium of the respiratory tract, and it entraps the pathogen that tries to enter the respiratory tract. And the cilia are hair-like projections of the epithelium which beat at the rate of about 1,000 times a minute, and they sweep out this mucus entrapped pathogen out into the outlet of the this respiratory system, that is up to the nose and mouth, from where they are expelled by coughing and sneezing. Now, this point is important because it forms the droplets containing the virus, and that would be infectious to others. And that is the reason why we should wear masks to protect others from getting the droplet infection and also not to receive the droplet infection from others. So you can see that cilia diagram, the other two diagrams, stercocilia and villi, they are not related at all to this context, but I cannot separate them from the image. Now you can see next is the antimicrobial substances, about which I will show later. You can see the macrophage image, back image please, back that image. The macrophage you can see here, macro means big, phase means it. So this is a phagocytic cell. It supposed to trap and engulf the pathogen, whatever it is. So this is another defense that is situated in the lung tissue proper. And these are called fixed macrophages because they just reside there. And as and when the pathogen approaches them, they deal with them. As against, there are wandering macrophages elsewhere, which are recruited to the site as and when needed. So it may take a little delay for them to arrive, but the locally situated these macrophages are ready to prevent entry into the lung. Now these are also called dust cells. They can filter even the particulate matter like dust and coal dust and all that. Now, lastly, the antimicrobial substances. A number of, slide please. A number of antimicrobial substances are secreted by the respiratory tract or epithelium, and some of which are being focused here. I am not going to details of these things, but all these have macrocytal, and their spectrum also is somewhat different. Some act only on bacteria, some act on all the pathogens, something like that. So, and they also differ the way they attack and kill the bacteria, that I will emphasize. The lysozymes, which are the intracellular enzymes, they attack the cell wall of the organism, mostly it's bacteria, and especially the peptidoglycan constituents of the cell wall. Now, let us skip the second one. I'll come to defensins and catalyticins. So these are negatively charged particles. The former attacks the host cell membrane and sets up it being a negatively charged particle, sets up an electrical gradient by which the membrane integrity is disrupted and the contents are leaked out, and thus the cell as well as the pathogen will die. And the next one will attack the cell membrane, lipid or glycolipid cell membrane of the microorganism within the phagosome. And this phagosome is nothing but a vacuole that is engulfing this pathogen as soon as it enters into the cell. So it is the lipid membrane of the microorganism that is attacked here, and the previous one attacks the cell membrane of the host itself, and the first one attacks the wall, cell wall of the microorganism, especially bacteria. Now, lactoferrins are having a broad spectrum of antimicrobial activity. Their main function is to bind and transport iron in the blood. Now, protease inhibitors, secretory protease inhibitors, these actually, proteases are damaging substances. Actually, these substances by some deranged mechanisms can cause damage to our own host tissue without the effort of any pathogen, like they cause damage in cystic lung disease and emphysema. The destruction wrought in these two conditions is because of this enzymes, and the inhibitors try to prevent that. That's how we have healthy lungs. And in case the microorganism you chooses this way, these inhibitors will prevent it from doing so. Now, summarizing, we have a wonderful system of defense right from the upper airways, guarding at the entrance point, at the pharynx and the nasopharynx, and throughout from pharynx down to the bronchus by means of the mucus, MALT, mucus associated lymphoid tissue, and then mucus and cilia. And lastly, if the pathogen is able to reach up to the lung point, we have alveolar macrophages, which will give the death blow, final death blow. So now, if the organism, say our COVID, if it can deceive all these systems, including the macrophages, then only they can enter the lung tissue and set up what is called the pneumonia process. And if they fail, the clinical spectrum, clinical entity is terminated at just short of pneumonia. So that's about the local defenses. Now, I told you that this local immunity will integrate the local defenses and then innate and adaptive immunity, immune mechanisms that are available. Now, what is the difference between innate and adaptive? I don't go into much detail. This is a vast subject. Innate is present right from the birth. It is germline origin. It doesn't need any organism or a vaccine to introduce it. But it is non-specific. It will act in the same way to any organism or pathogen. But the advantage is it is the first to appear, first to encounter the pathogen, and it is called into action immediately as soon as the pathogen enters into the body. Now, so this is the first line of defense from the systemic immunity point of view. And regarding the adaptive immunity, it is induced once the microorganism or the virus here enters, it sets up a reaction and then induces antibodies or cell-mediated immunity. So it needs the exposure to the organism or exposure to the vaccine, in which case only the adaptive immunity will develop. And this adaptive immunity takes time to develop, maybe a week or so, or even more to develop. So they come late in the picture, in the second week or so. So meanwhile, the protection is by the innate defense mechanisms. They can either help or even do harm, and how they does the harm is out of scope of this. They can do the harm, and I firmly believe that does harm, and that is my next paper or whatever it is. Here we are not going to discuss about it. Now, the main constituents of this are humoral and cellular. Humoral being antibodies and complement, which differ in each of the systems. In case of innate immunity, they are natural antibodies, and along with this conventional IgG, IgM, and IgA. And in case of the complement, the innate works by activating the alternative pathway. There are three pathways, and one of them used by innate system is alternate pathway, and the adaptive uses a classical pathway. And regarding the cellular elements, natural killer cells are there. Then here cytotoxic cells there in the adaptive immunity. And since this innate immunity is more important, I'll just enlarge the scope of this innate immunity, the cells of the immunity, components of the innate immunity, slightly immunity components of the. So most of the components are already covered. In addition, there are few items left. And in addition to alternative pathway, there is MBL pathway or lectin pathway, which also is used. And then we have trexins and collectins. So these are some of the things in addition to what we have seen. And I'll show you the pictorial form of this cellular element of innate, just to show you. I will not talk about them. Cells, please, cells of the innate system. Now you can see a number of cells. Now you should be thankful to God or whatever it is, the Supreme Person, for having provided so many of the cells that are being in our defense, like our soldiers at the border. So you can see, if you roughly draw a line in from 6 o'clock or 7 o'clock, sorry, to say 1 o'clock to 7 o'clock or whatever it is, the one on the left side are mostly phagocytic. That means they entrap and engulf the bacteria. And all those designated with the T, they are all variants of T cells. They kill the bacteria by their mechanism, which may be complement mediate or otherwise. So this is about the this is how this local immunity works by recruiting the innate and as well as the we'll next move on to the basis. We have seen as three there are three aspects to cite the basis or proof of existence of this mucosal or local immunity. We have seen already the local defenses. The second one is and this concept and go Breska's conclusions. Professor Breska, working in Pasteur Institute in 1924, he has experimented on mice with anthrax bacillus. This is a bacillus which causes, it enters through the skin and causes a skin disease. And it's a different matter. When inhaled, it can cause a lung disease. We are not bothered about that. Now we concentrate on the skin part of it. Now he has taken this anthrax bacillus, injected intraperitoneally, that means into the abdomen, and he found that neither it protected the organism nor it produced any humoral antibody. He tried the same by changing the route, by approaching through the skin, and mind you, it is the route through which the pathogen also is entering. Now, miraculously, he found that the organism, so the mice is protected by the subsequent challenge of the virus, even though no humoral antibodies are to be found. Now, this has great conclusions that if you immunize the way, the route in which the pathogen enters, the protection is far better, and the protection is independent of any humoral element, humoral antibody. And antibody may not be produced in some of these infections which choose to go through some tissue or other than the blood. So these are his conclusions. Now, what is the proof we have from the experimental data? So this concept has been applied to some of the bacterial and viral diseases. So please focus the slide. So the bacterial diseases are the Vibrio cholera, Salmonella, and then Mycoplasma. We are interested in the viral part of it, influenza virus and poliomyelitis virus. Now, we will see the poliomyelitis. In poliomyelitis, the virus enters by fecal-oral route into the intestine and then spread systemically and cause problems. Now, in that process, it protects the intestinal mucosa. And how do you know that the intestinal mucosa through which it is passing or transported is immunized? So when a viral load was studied in the stools, those who were immunized with oral polio vaccine, the antigen load or the viral load is less than those who have been vaccinated by other sorts of vaccines systemically or parenterally. So that means there is definite protection offered by this local transmission of the through this favorite tissue. It doesn't enter through any other tissue, but here there is, it's not exactly tropism. but there is a liking for this, which is seen also in COVID. Now, in influenza also, it's a respiratory disease, and it is clearly distinguished from COVID. There are so many points, but basically both are respiratory pathogen. So a vaccine has been developed, which is, say again, this virus enters through the nose and affects the respiratory system. So a vaccine has been developed that is administered internationally, which is effective, and its effectiveness in comparison with other routes of vaccine administration has not been commented by CDC. So it is as effective as the other vaccine. So this has this study on this virus, influenza virus, has given some clues. Mostly the antibody that is seen is IgA, and to be effective, the vaccine has to its ability to secrete or produce large amounts of IgA is related to the efficacy of the vaccine. And then it is also seen that the protection runs concurrently with the level of IgA rather than IgG or IgM. And high levels of IgA, IgM or IgA or any other serum antibodies, they have no protective role. That's what is found in some of the studies. The studies may vary. Again, the another important factor is there is no blood dissemination as evidenced by failure to recover the influenza virus from the blood. And some of these characteristics are drawn by COVID virus being a respiratory pathogen also. Now, the principal antibody that is formed, that is coming into fore in mucosal immunity is IgA. Now, this is secreted locally by the epithelial cells in response to the pathogen which enters through the mucosa. Now, if you measure the serum levels or blood levels, it's comparatively very, very low, and that's what we do. And we ascribe significance to the levels of this antibody found in the, and large amounts of antibody are found in blood, that IgM and IgG, and so they are given due respect. And IgG, as measured in the blood, is very low, so it is relegated to a non-important position usually. But in case of mucosal infection, it is high levels. It is seen that high levels of IgA are seen, irrespective whether there is IgM or IgA response, or even if the response of IgA, IgM are there in the serum or the blood, it doesn't match the IgA. So IgA is the hero here in local or mucosal infection. And what does it do? Now, when the pathogen attaches to the human cell, it activates or expresses a receptor called IgR, polymeric IgR, PIGR, which is supposed to transport this immunoglobulin IgA outside, so that it will prevent the adherence of the pathogen to the cell. Now it does another, this receptor does another important function. If the pathogen tries to break this barrier and enter the cell, even then this receptor will transport the pathogen back into the lumen and expose it to IgA, which does the finishing job of the pathogen. Another important thing of IgA is it neutralizes. It is seen to neutralizes the pathogen and also the inflammatory products. So more and more of importance is given to IgA. Now what I want to stress is it is the IgA which is going to confer and in local immunity, the immunity of the mucosal system. And the correct guide is to enhance this IgA than to enhance IgG or IgM in the blood. That's what I believe. Now, I will go to, I will make a concept out of this. Actually, utilizing all these facts, I want to make a concept. Now, let us see that this COVID virus enters through the nose or nasal epithelium, multiplies there in the nasal epithelium, and finally, it is excreted through the nasal secretion out of the body. So it does not seem to affect any other tissue, and in this way, it seems to have some sort of tissue tropism, but so far it has not been considered as a tropic virus to mucous membrane or anything, but the facts speak otherwise. Now, supposing we have recently seen that the coronavirus has been reported in the fecal matter, and but it has not been reported to cause any pathogenic damage to the intestinal wall. Why? Because it is not the favorite mucosa for the COVID virus to multiply, attack, and cause damage. That's the inescapable conclusion. Then why they are present in the stools? Probably they represent the swallowed saliva or phlegm, and they just are washed out through the fecal matter. Now, it means it is another support to the tropic theory of COVID towards the mucus, respiratory mucus, mucosa. Now, it's also seen that it is almost confined to the respiratory system, and there is no evidence that there is viremia, primary or secondary. That means there is no dissemination into the blood, because it has not been recovered from the blood. And even in blood transfusion, it was declared by the WHO that there is no need to screen for COVID virus when you are considering a blood transfusion. Now, this may pose a very awkward question. In that case, how do you reconcile with the reports of involvement of the heart, kidney, brain, and even skin? There are several reports. I can't say several. There are few reports of involvement of these systems in COVID-19 disease. But there is no proof that it is actually due to the presence of virus, or no proof has been provided of the multiplication and pathogenicity of the virus itself. Even the autopsies failed to demonstrate the virus in these organisms. Now, probably the involvement of all these organs is because of the spillover of the immune responses mounted by the body, and usually they don't spill out, but when overwhelming reaction occurs, like what you call storm, immune storm, so these leak out and they can attack these. And then why choose these four tissues? It is the presence of the same receptor which invites the pathogen into the lung tissue, that is ACE2 receptor. All these tissues have ACE2 receptor, and the mere presence of ACE2 in other tissues like heart, kidney, and brain, and the skin doesn't mean that the virus is going to enter there, because we have seen that it has preference, and the preference is to the respiratory epithelium. So again, it goes to say that the infection is strictly confined to the respiratory system. Now, to start with, the infection is limited to the upper airways, and only when it becomes vulnerable, the host becomes vulnerable, it spreads to the lower respiratory tract and then into the lung, making its way into the lung. Now, there are many radials about this COVID manifestation, and which can be explained by this concept. First is how is it that 80% of the people escape the serious consequence of pneumonia and while only 20% are affected? Perhaps the overwhelming local immunity is responsible for the prevention of the pathogen to enter into the lung in 80% of the cases who are healthy, young, and otherwise have no morbid problem, comorbids problems. So this is one reason we can ascribe. Second thing, why COPD and asthma patients are more prone to COVID virus disease? This is because one is infective etiology, another is hypersensitive etiology. In both ways, the immune mechanisms of the local immune mechanisms of the respiratory tract are already damaged, and it is easy for the COVID virus just to walk in and pass through the tract and enter the lung. So they are more susceptible. Now again, the more important thing is the asymptomatic carrier, which is worrying everybody nowadays. So we don't recognize the people having this infection, but yet they can transmit the infection. Now this can be also explained by this mucosal theory, because the predominant immunoglobulin in the mucosal resistance or local immunity is IgA, and this is the first to react with the pathogen, and IgA does not activate the complement, and unless the complement is activated, the inflammatory element doesn't come in, and the symptoms which we see are of inflammatory origin produced by the body, not by the virus. It's a reaction of the body to the virus. So since IgA doesn't activate the complement, so those people in whom the IgA is high may remain asymptomatic. This is one of the tenets of the concept. And reinfection, this is also another problem. Even after the incubation period of 14 days, people are seen to be infected, or are they reinfected? So this also explained because the predominant immunity, as per my concept, is local immunity mediated by IgA, which has no memory function. There is no memory function in the innate system or in the IgA response. So this memory system or TH cells are a part of the adaptive immunity and in a subgroup of T cells. So lack of this memory make the organism vulnerable for the second attack should the same organism attack the same person. So it doesn't recognize, so it doesn't fight. Once the memory cells are activated, they resist the second entry, so no reinfection. Now, the presence of reinfection, suspected reinfection, also falls in line with this concept. Now, thirdly, why old people are affected? Now, there are several reasons given, like comorbidities, like diabetes, heart disease, hypertension, all these things. The more important, I think, is the decline of this local mucosal system by age as well as by abuse. The abuse is by several means: smoking, exposure to the dust, exposure to pollutants, and all these things. And secondly, we have talked of ACE2 receptor, which actually is meant for protection of the lung tissue. It upregulates the function of the lung, but it is manipulated by the COVID virus and use it as an entry point into the lung. So that is the wisdom of COVID virus. So that's why there is a dilemma in the in the minds of the cardiologist whether to stop the ACE inhibitor or continue. And the consensus is that they should continue. Whoever are taking should continue until more evidence comes. Anyway, so there is a decline of this ACE2 inhibitor response as age goes on, and this could be one of the reasons of the vulnerability of the old people, apart from the other things we have already considered. Now, what does all this mean? So, we have a multi-pronged attack at the level of the entry of the organism will prevent entry into the organism, entry into the host of the organism, multiplication of the organism in the host, and excretion of the organism through the nose. So three-pronged attack is there if you enhance the local immunity of the nasal epithelium and respiratory epithelium in general. Now, how is it possible? How is it possible? Yes, it is possible, but because this immunity can be induced or induction of this immunity by a proper vaccine that is administered. Now we see that induction of this vaccine, the disease has no natural protection, so we have to depend on the vaccine that is prepared and administered. Now the route of the administration of the vaccine determines the type of response, immunity that is given, as we have seen in case of influenza and poliomyelitis and other things. Now, if the local entry point epithelium is trying to attack the pathogen, arrest it and expel it, so a vaccine that could boost this sort of immunity would be welcome, and that is a vaccine that can be administered intranasally. So, in conclusion, I say that the local immunity plays much greater role than what has been thought of, and it also takes into account the local defenses as well as innate and adaptive immunities. And there is ample evidence that the local mucosal immunity has existed by these experiments and the disease in which they have been successfully employed. And so the future is perhaps in the hands of the vaccine, which is administered nasally, intranasally, that would activate this local immune system rather than approaching systemically and raising an ineffective antibody. It is also seen that the systemic antibody may not be able to protect the local tissues, and locally produced antibody may not be able to reach the in good quantities into the say in the blood. That is the reason why IgA is very less in the blood. So anyway, my contention is the research can be oriented on the local factors, local immunity, and again, what sort of vaccine, a killed vaccine or a live attenuated vaccine? This is a big question, and it has already been seen that if you use a killed vaccine, it is 100 times less potent than a live. You cannot use the direct pathogen, a live attenuated vaccine. So it is up to these pharma industries who are after this vaccine, either to use this intranasal route to administer the vaccine, either a live attenuated or a killed one. But the route is important, and the immunity that is evoked is important. And this is in nutshell, my concept about local immunity. This has been published already, as already told in the Asian Journal of Immunology in April 2, 2020, from which people can access this article. And again, this article is supplied to the organizer, and you can obtain this article, because all these facts are quoted by references. These are not cooked up data, and we can't cite these references here. But all these facts are drawn from the article, and all have been given the references, due references, and that gives a little authenticity. Now, it is something different, and anything different is difficult to be accepted. And now I leave it to the wisdom of the scientific community to draw anything good out of this concept, or just leave it to its own fate. Thank you very much.
Absolutely. We actually have a question here for you, Dr.
Yeah, sir. Yes, sir. Go ahead, sir.
From Richard Awiki. Thank you very much for your talk, Dr. Asp. It was very good to know this concept of local immunity development. I think it's very important to know more about this in the development of the vaccine. So we have the question from Richard Awiki, who's asking Dr. Prasad, kindly comment on the time taken for asymptomatics to become symptomatic, and if the SARS-CoV-2, like other viruses, may occur. What is the latest on vaccine development for future pandemics of COVID-19? Can you see the question on the Q&A, Dr. Asp?
Yeah, you want, it's not very clear. You want you want to talk about ask about the vaccine. A candidate for the vaccine? Which virus should be the candidate of the vaccine? Is it that what you want to ask? Hello, sir. I could not get your, make it short and, I mean, to the point. What is it that you want? Reply
What is
from
the
me.
latest, Richard is asking, what is the latest on vaccine development for the future pandemic?
Oh, I got it. You want me to comment on the latest information of the vaccine trial?
Yes.
Yes, isn't it? But unfortunately, I have not equipped myself with the latest details. But I can see that the candidates of the vaccine are the capsid antigen, S antigen, and the mRNA is also a candidate. And then capsid antigens. These are three antigens that have been considered by different laboratories, and they are processed in different ways, and mostly they follow the recombinant technology by reconstructing the sequence in the laboratory and introducing and hoping that the body will react in the same way to this introduced sequence as it reacts to the body. And in any case, I have not concentrated on the vaccine aspect because, yeah, as I could update, some 35 countries are after this vaccine, and many countries have come up to the clinical trials, phase 1, phase 2, and WHO and other organizations have even what do you call allowed to skip the animal test, but that is not proper. I think I don't think it is proper to skip, because by the time you develop vaccine, maybe the COVID will disappear. That's what I fondly hope for. And then what for this vaccine? Unless it returns, and that fear also is that it may return again in November, December. And these are all personal opinions. Nobody, COVID has told nobody that it will come back. So we can see the SARS virus 1. It has vanished in 2003, after 2003, and never to return. But unfortunately, we could have done a lot of work on SARS 1, which has been pandemic and which has got a 34% mortality than the present COVID. Work should have been done, and before any work could be done, the virus has vanished, and then it presented in some other form, MERS, COVID, and now COVID-19. All these belong to the same group, but maybe by changing the antigenic structure, we are getting more and more of these viruses. And even in coronavirus, because of the way they are behaving, the coronavirus is behaving in different countries. It is felt that there are many strains, and there are even, they talk of 37 mutations. That is, I think, is an exaggeration. At least 2 mutations are known to occur at position 72, and then some 17 or 90, something like that, which they have called as S type and L type, and some Oxfordians says A, B, C type. But there is no clear-cut evidence that A attacks the Spain, B attacks the Italy, C attacks America. There is nothing like that. It's all in the hypothesis,
because it's all very
speculations only. And I'm sorry that I cannot give more information because I'm not prepared about the vaccine. I have fully concentrated on the mucosal concept, because as I told, it is the Cinderella of immunity. Thank you, sir. Thank you very much.
Thank you very much for your talk, Dr. Asp. Thank you for being on this conference, and thank you for your presence.